Hey everyone! Have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone! So in the last video, we were able to find our approximate solution to this problem using this quadratic equation, using our approximate solution by looking at the negative to positive or positive to negative approach. So in the beginning, we were using an exact solution and trying to find exactly when this function was equal to 0, or fun was equal to 0, to find the root, to find where this x-axis is. But then we talked about it a bit and we realized that for a lot of problems, these roots are going to be so precise in terms of decimal numbers that we're never going to find the exact solution, even when using something like 0.0001, right? We won't find the exact solution. In that case, we wanted to settle for this approximate solution. And the way we found that was finding places where it went from positive to negative or negative to positive, just using the properties of a parabola that we know would be where these roots are. That's what we've done up to now. We've largely solved the problem we set out to solve, which was finding the roots of a quadratic equation without using the quadratic formula, using programming. Yeah, we're there most of the way there now. Now, there's two main things I want to talk about. First, we want to talk about the actual quadratic formula and why is this useful if we know the quadratic formula. I mentioned before that there is a formula that is used to solve it, and it is this formula right here. Now, you might recognize it from seeing it. This formula is something that I have memorized and many people have memorized. It's negative b plus or minus the square root of b squared minus 4ac over 2a. And that will give you the 2, 1, or 0 roots that are going to be the roots of this equation. Now, if this number in here is negative, you can't take the square root of a negative number, and so you don't have any real roots. So that's how you would have a number up here. And it's possible that you end up with the same number. That's how you get one root. But for most cases, you're going to get plus or minus a number, and that's going to be your two roots, one plus and one minus. And so these b, a, and c refer to the coefficients, the numbers that are in front of these values. And this is what we've been toggling and changing to get different results. So see here, b was 0.02, c was 0.0001, a has been 1 in all of these cases, b is negative 302, c was positive 600. So this is what we've been iterating through with all these different versions of these quadratic equations. But there is an actual solution, and that is calculated in this way. First of all, I wanted to just show what that was for this approximate solution that we weren't able to get. So I plugged this in, right? This is the b was equal to negative 6. So in this case, negative b is 6, and then I plugged everything in here. C was equal to 7 over 4, and a was equal to 1. So just plugging this in here using just Python as a calculator, I got the two answers, which is 5.69258 and 0.37417. And you can see that these numbers are actually pretty close to the ones that we approximated, 0.308 and 5.693. And that was to 3 decimal places of precision. So our function works, and it gives us similar answers to the quadratic formula. Now, the question that you might think is, if we have this formula, what's the point of even doing this? And in some ways you're right, in some ways you're wrong. I completely understand that thought process. And it's true that we do have an exact solution. And in general, if you ever want to find a root to a quadratic equation in the future, don't do this. Definitely use this formula. It's easier, it's straightforward, and it's exact. You'll always get the right answer using this formula. However, thinking about it in another way, this whole framework gives us a way of solving problems without using algebra and without using math. So if we didn't know how to do the algebra to solve the quadratic formula, we could still use this guess and check and approximate method to find an approximate solution to this problem. Secondly, there's a lot of problems out there that we can't solve in a simple way like this with just a simple formula. If you make this whole problem more complicated, it might not be possible to solve it this way. However, you can always find a solution using a similar approach to what we did here with this approximate solution. So it represents a different way of thinking about problems than algebra and math. And we want to emphasize that. And this was what this whole the purpose of this was. You can imagine that you could put in any formula here, right? It doesn't have to be a quadratic equation. You could put in something complicated that maybe there's no way of solving for where there's going to be 0, or not a simple way of doing so. And you will get a solution, right? And you can imagine even harder problems than this that would generally be hard to solve. You can use this approximate solution where an exact solution is not possible to find using math. So this is the idea, is that we wanted to use programming to solve this problem without using algebra itself to solve for it. Now, it's encouraging that our results are similar here. Now, one thing I would suggest, and this is another idea, is that we can do this in this way, right? Where we plug in every single number, but this is pretty arduous, right? So the way I mentioned before that we could do this is like this, right? So, and we talked about this before when we were talking about variables, but maybe a little bit of a cleaner and easier way of handling this would be to set a, b, and c as variables and then make this in terms of a, b, and c. So you have negative b plus b squared minus 4 times a times c. And we're going to have this whole thing to the 1/2 power. And then we're going to divide this by 2 times a. So we're going to write it out exactly like that original formula was, and we're going to get the same solution. We have this, and we have minus this. So actually what we're going to do is we're going to do this, and we're going to store this as a list, and we're going to use this same value here and just put minus in there as well. So now we can store both roots in one single list. And sorry, I didn't have minus, so I have to add the minus. Okay, so this is a bit of an easier way of handling this problem, where we're going to plug in numbers as variables and then have our formula here, which is nice. And now we can move these around. So if we made A2, we could solve it. A15, we could solve it. And probably a nicer way of handling this is using so if we remember the original equation we were trying to solve, all the way up here was using 1, -4, and 7/4. So if we solve for that, just to do a quick sense check, then we could do 1, -4, and 7/4. And then we get the answers that we found before. Now we were able to find those exactly because we were going up by 0.1, and it was 3.5 and 0.5. And in the very, very first one that we did, we actually had c equal to 0 and b equal to -3, and this was the exact solution we found there. That was completely guess and check, right? So this is going through all the different methods that we had used and plugging it into the formula and making sure we get the same result, and we do, right? So it's illustrating that this is two different ways of solving this problem. Now, another nice thing that I'd like to take this time to explain, is using a function. So the quadratic formula is a function. It's a function of 3 variables, a, b, and c, right? This is a nasty formula, and we don't like remembering it, right? And even here, it's still nasty. We still have to have this function doing these things for us right here in a cell. We can use a function so that we don't ever have to think about negative b plus or minus the square root of b squared minus 4ac over 2a ever again. And the way that we would do this is we would write def, and this defines a function. We say quadratic function. We open up with parentheses. Now, inside of the parentheses, we're going to put what we call arguments. There are arguments to this function. In this case, the 3 arguments or parameters are a, b, and c. So we're going to say a, comma, b, comma, c. And then I'm going to write a colon. Okay, if I press enter, it's going to tab for me, which is going to basically we're going to write our code in this function. So I'm going to do something inside of this function. So I'm going to write this do something, and then I'm going to return some value. And when I return that value, we're going to see what that does. So I'm actually just going to take all of this code I have up here, and I'm going to put it inside of here. And I'm going to see, because there's a problem with the indenting, I'm going to indent it all out. And Jupyter, by the way, if you select a bunch of text and you hit tab, it will actually indent everything. And if you hit shift tab, it will unindent everything, just so you know. And I'm going to actually assign, rather than just having this list here that's just sitting here, I'm going to assign this to a variable called roots. And I'm going to move this over just so it looks a little nicer. You don't actually have to do that, but it looks nicer this way. And then I'm going to return the roots. So this is what I'm going to do. I'm going to making a function, takes an a, b, and c, and it's going to do this. Now, here I'm setting a, b, and c to specific values. But I'm not going to do that. I'm going to actually remove this. Because it's inside of a function, the values that I put into here are going to be replaced in this roots list by the values that I pass in. Let me explain this. I think it's the easiest way to explain this is by illustrating it. So I've created this function, and now if I write quadratic function and put in 1, -3, 0, it returns this list, the same list that I had here. Now, what is going on here? Here, I basically am telling this function, I want a to be 1, b to be -3, and c to be 0. And then inside of the function, it runs everything and returns basically outputs this list of the two roots. So now, instead of having to remember this function or plug it into this specific formula, I can start putting in numbers into here and A, B, and C, and it will give me the correct answers. 2, -5, and 0 gives me a root of 2.5 and 0. Now going back up to the problem we were trying to solve was 1, 6, and 7 over -6 and 7 over 4. And we're going to get these long decimal places that we approximated ourselves here. This is another thing. If we don't ever want to use the quadratic formula again, we can use this, we can define this function once, and then from then on, we never have to think about -b plus or minus the square root of b squared minus 4ac over 2a. We can just put in a, b, and c into the correct positions in this function and call quadratic function. Now, as I mentioned, functions return particular values. If I didn't have this here, and I just did this, it wouldn't return anything and nothing would be returned. So it would do all of the calculations in here, but it would never actually spit anything out. What I wanted to do is to return the roots here. And this could be arbitrarily long, right? So this could be much longer than just this one line of code. There could be much more lines of code, but all that's going to be returned is what I put in this return part. Okay, this was a little bit of an opportunity to talk about the quadratic function, the quadratic formula, and using our quadratic function to calculate the roots for using the quadratic formula, and also a bit of a discussion on why we might want to use this if we use this method, even if we have an exact solution. I think using this method is much more applicable generally to problems. This is a specific solution to this one specific problem. Now, in the next video, I'm going to talk about a couple of things that we could clean up about this code up here to make it just easier to work with and just easier overall using some of the new knowledge that we have about this quadratic, about using functions and the quadratic formula.